NCERT Physics Class 11 5th chapter, which is Laws of Motion, question number 5.10. So now a body of mass 0.4 kg moving initially with a speed of 10 meter per second. Initially with constant speed of 10 meter per second to the north is subject to a force of 8 Newton directed toward the south for 30 seconds. Take the instant when force is applied to be 0 second. So in this we have to define the position of particle as given t equal to -5, t equal to 25 and t equal to 100 seconds. So let's say a force of at 8 Newton start acting on the body at t equal to 0 second. So at t equal to 0, a force of 8 Newton start acting in the direction which is south. And initially the particle is moving in north direction with the speed 10 meter per second. Now due to this force, the speed of particle will reduce as it is retarded motion. So at t equal to 0, the force of 8 Newton start acting on the body in direction opposite to velocity. And this t equal to, what is the significance of t equal to -5? T equal to -5 means 5 seconds before acting the force. So this is t equal to -5. So before this t equal to 0, the particle is moving with constant speed which is equal to 10 meter per second. So we have to define the position at t equal to -5 at, let's say, the position at t equal to 0 is x equal to 0. So we have to define the position before acting the force, 5 seconds before acting the force. So in this case, initially the particle is moving with constant speed, that is 10 meter per second. So in order to find this distance in 5 seconds, we can use d is equal to, distance is equal to speed into time. So this distance is equal to speed is 10 and time is 5. This distance is equal to 50 meter. So if this coordinate equal to x equal to 0 and we are moving in left direction, so its coordinate would be x equal to minus of 50 meter. So at t equal to -5 second, the coordinate of particle is x equal to -50 meter. Now second part at t equal to 25 second. Now second part is t equal to 25 second. We know that at t equal to 0, x equal to 0. So at t equal to 25 second. T equal to 25 second. So a constant force act up to t equal to 30 second. So we can say that the value of acceleration can be found out by F equal to m into a. So net force acting on the body is 8 Newton. Mass is equal to 0.4 kg into a. So from this we can say that acceleration of body comes out to be 20 meter per second square. So this acceleration is opposite to initial velocity. So this is case of retardation. The acceleration in this case is opposite to direction of initial velocity. So in order to find out the coordinate at t equal to 25 second, we can use equation of motion as acceleration is constant s equal to ut plus half at square, where s represent final position, that is position at t equal to 25 minus position at t equal to 0 is equal to u into t. So initial velocity is 10, time is 25 plus acceleration would be minus 20, as sign of velocity and acceleration are opposite. So if you have taken u with positive sign, so a would come with negative sign, which is equal to minus 20 into time, that is 25 square. So the position at t equal to 0 is 0. So position at t equal to 25 can be given as 250 minus of 6250. So position at t equal to 25 comes out to be minus 6000 meter. Now third part, we have to define the position at t equal to 100 seconds. So in this case, throughout the time, the particle is not accelerated. So the particle is accelerated only up to t equal to 8 seconds. Sorry, up to t equal to 30 seconds. In this case, the acceleration is only up to t equal to 30 seconds. So from t equal to 30 to t equal to 100, the particle move with constant speed, and which will be equal to speed at 30 seconds. So first we are going to find out the displacement in 30 seconds. So in this case, acceleration is constant. We can use equation of motion as s is equal to ut plus half at square. Displacement is x at 30 minus x at t equal to 0 is equal to initial velocity, that is 10, into time, that is 30. Acceleration would be minus of 20, as again velocity and acceleration are opposite direction. So if we have taken velocity as positive, then acceleration would be negative into 30 square. So as we all know, position at t equal to 0 is 0. So from this we can have the position at t equal to 30 second is equal to minus of 8700 meter. Minus indicate the particle is in left side of horizon, and which is 8700 meter from horizon in left direction. Now at t equal to 30 second, the position of particle is minus 8700 meter. Now let's find the speed of particle at that time. Speed of particle at t equal to 30 second can be found by using v equal to u plus at equation of motion. So by using v equal to u plus at, v equal to u plus a into t. So final velocity, that is initial, that is 10, acceleration is minus 20, into time, that is 30. So from this we have v is equal to minus of 590 meter per second. This minus indicate the velocity of particle is in negative direction or in left direction. So the particle will continue to move in left direction. So now find out the distance traveled by the particle from t equal to 30 to t equal to 100 second. So in this case, v is constant. Now after 30 second, no force is there. This implies that v is constant. So distance traveled by the particle in these next 70 seconds can be find out by using d dash is equal to v dash into time, t dash. So next distance is equal to speed, which is equal to at final speed, that is 590, into remaining time, which is 70 seconds. So this comes out to be 41,300 meter. So as we all know, initially the speed as negative direction. So this particle will cover distance 41,300 meter in left direction. Initially the particle was, this is initially x equal to 0, at t equal to 30, this coordinate was minus of 8700, and finally from this t equal to 30 to t equal to 100, it will cover a distance of 41,300 meter. So finally this coordinate at t equal to 100 can be written as, so final coordinate at t equal to 100 can be written as minus of 8700 minus of 41,300. So this comes out to be position at t equal to 100 is equal to minus of 50,000 meter.